Welcome to another lesson in your electrical training journey. Today, we're focusing on a concept that's not just important in the classroom, but a huge part of real-world electrical and faculty work. Lighting upgrades. What they are, why we do them, and how they save both energy and money. So why was this topic created? The reason this topic matters is simple. Most buildings in use today are decades old. That means a lot of them still have outdated lighting systems, like old fluorescent tubes, magnetic ballasts, or even incandescent bulbs. When these buildings were built, those systems were the best available. But today's technology has evolved, and today's lighting is more efficient, more flexible, and much more cheaper to operate. This lesson was created to help you, as someone entering the electrical field, understand the benefits of upgrading lighting systems. You'll also learn how to calculate savings and explain upgrades to building owners. A lighting upgrade, sometimes called a retrofit, is when you take out older, less efficient lighting components and replace them with new, energy-efficient ones. This could include replacing old T12 fluorescent tubes with T8s or LEDs, swapping out magnetic ballasts for electronic ones, replacing incandescent bulbs with CFLs or LEDs, or adding automatic lighting controls like occupancy sensors or daylight harvesting. The goal is to have the same or better light output, use less energy, and lower costs. Let's break this down using a real-world example. Imagine we have a 100-watt incandescent light bulb that we use 8 hours a day, every day. That's 2,920 hours per year. Now let's say we replace it with a 27-watt compact fluorescent lamp or CFL. It gives off about the same amount of light, but uses much less energy. Here's an energy comparison. For the incandescent, we have 100 watts multiplied by 2,920 hours, which gives us 292 kilowatt hours. For the CFL, or compact fluorescent, we have 27 watts multiplied by 2,920 hours, which gives us 78 kilowatt hours. At 10 cents per kilowatt, here's the yearly cost to operate each. For the incandescent, that would be $29.20. For the CFL, it would be $7.88. That's a savings of $21.32 per year for just one bulb. Now here's the part many owners care about. The CFL costs $7 and the incandescent costs $1. The CFL costs 7 times more upfront, which may make people hesitate. But the CFL lasts 10 times longer and saves a lot of electricity. So how long until the energy savings cover the cost of the new CFL? So the payback would equal the cost divided by the annual savings. So the cost of $7 divided by the annual savings of $21.32 would equal about 4 months. After that, it's all profit. So if the CFL lasts 10,000 hours, That's about 3.4 years of use. The profit would equal $20.32 multiplied by 3.4, which is about $73. So, for a $7 investment, the owner gets $73 in savings. That's a return on investment of about 300%. They triple their money. Lighting upgrade projects can involve hundreds or thousands of fixtures. So when you multiply those savings across an entire building or a campus or a warehouse, you're talking about massive savings. These savings can help cut monthly utility bills, reduce maintenance time, lower environmental impact, improve light quality and safety, and increase the value of the building. That is why lighting management companies often lead these upgrade projects. They help owners save money and energy without sacrificing light quality. As a new technician, your role in a lighting upgrade might involve removing old fixtures or ballasts, installing new LED lamps, drivers, or smart controls, testing lighting levels to ensure quality, explaining energy savings to supervisors or clients, helping with maintenance schedules to protect the investment. You may also be asked to help calculate energy usage using this formula. Energy in kilowatts equals watts times hours divided by 1000. Or calculate payback like this. Payback in months equals costs divided by annual savings multiplied by 12. Or return on investment. ROI percent equals annual savings divided by the cost multiplied by 100. These numbers help customers make smart decisions and help you stand out as a knowledgeable technician. Before we wrap up, here are a few things to keep in mind. Always check compatibility. For example, make sure the new LED drivers or ballasts match the controls and wiring setup. Measure light output. Use a light meter to confirm the new system meets the brightness requirements. Dispose of old components safely. CFLs and older lamps may contain mercury or hazardous materials. Document everything. Keep records of energy savings, part numbers, and installation dates. Safety first. Follow lockout, tagout, and PPE protocols during every install. Let's review the key points of what we've learned. Lighting upgrades replace old systems with energy-efficient ones. They can cut lighting costs by 50% to 80%. Even if a new lamp costs more, it saves money over time. Payback is usually fast, sometimes in just a few months. The long-term savings put cash back in the owner's pocket. These projects are a growing part of electrical work today. Understanding savings, return on investment, and payback will make you a better technician and communicator. That's it for today's lesson on lighting upgrades. As you move forward in your training, remember, your job isn't just to install lights. It's to install smart solutions that help buildings save energy, operate better, and reduce their impact on the environment. Stay sharp, keep learning, and we'll see you in the next session.